All right, we're just continuing here. It looks like this video is going to be for this exercise still, practice 521. Now we're just going to look at the next section of problems here. So I'm not writing much down here. I'm just kind of going over them, giving you strategies. Okay, so let's see. For problems 5 and 6, the following transformations represent dilations. Determine the scale factor and whether the dilation is an enlargement, a reduction, or a congruent transformation. All right, so here's the thing. We got to look at just what these mean, right? A dilation is an enlargement. Okay, so a dilation has a scale factor that is greater than 1, it's going to make it larger, right? So if it has a scale factor of 2, then that means we would have, if I was going from this small pre-image to a new image, if the scale factor was 2, from 4 it would go to 8, from 3 it would go to 6, from 5 it would go to 10. Okay, so obviously it's a little larger than 2 because we go from 4 to 10. Okay, so this is going to be an enlargement. We could tell. A reduction would go from the pre-image to the image. So the pre-image is before the transformation to the image. A reduction would just be a scale factor that's less, right? So it becomes smaller. Okay. A congruent transformation is where it does not change the size and shape of our polygon. A congruent transformation would be if P and P prime and the triangle here, if it would be a congruent transformation would be the image P prime, Q prime, R prime would be 4, 5, and 3. It would match the original. So congruent, remember, means the same. And that's a perfect example here because congruent is the same shape with the same lengths, just in a different position. That's why it's not equal. Equal and congruent are different because equal would be exactly the same in the same position, exactly the same. Congruent means same shape, different position. Okay, so if I look here, to go from 4 to 10, we multiply by 2.5. To go from 3 to 7.5, we multiply by 2.5. 5 to 12.5, 2.5. So it looks like we have an enlargement, dilation that's an enlargement with the scale factor of 2.5 for this. Okay, so now let's look down here. I'm just going to check out 7 real quick. Okay. I think we could just go through all these problems. I hope you're not looking at these before you've done them. It's better to review after. Okay, so make sure you're doing that. All right, so here's the deal. We need to again see if this is a enlargement, reduction, or congruent. We know it's not congruent, right? Obviously, it's not congruent because it's different. It's not the exact same in the exact same position. Okay, so look, we could do this from the sides here. Let's find an easy one to deal with. They're all not very easy. So look, 17.5 and 14. What do we multiply 14 by in order to get 17.5? What we can do with that is you could think of it as, let's see, 14 times something is equal to 17.5. So 14 times something is equal to 17.5. To find that something we multiply by, I can divide the left side by 14. So I divide both sides by 14. 17.5 divided by 14. 17.5 divided by 14 is 1.25. So I'm going to say this is a scale factor 1.25. Let's double check to see if that works. So let's see. Let's see if this works. If I have a scale factor 1.25, I take 14, I multiply by 1.25. 17.5. Let's see if the other ones work. 9.2, right? 9.2 times 1.25, which I said was my scale factor. 11.5. Oh, look at that. All right, let's do one last one because it's always good to do. Oops, not 4e4. 4.4 down here for SR. 4.4 times 1.25 is 5.5. All right, I'm just going to be super thorough. 11.6 times 1.25, 14.5. Yes, we know that this is what? Let's look at our options again. This is either an enlargement, reduction, or congruent transformation. Not a congruent transformation, it's not the same. But look, it got bigger. The pre-image is where you start. The prime image is, the image outcome is our prime values. So we have pre-image, that's where we started. Image is always the prime, and that looks like we have a scale factor 1.25. So yes, this is a dilation enlargement. Okay. Lastly, it's about the same thing here, okay? 7 is exactly like 6. 7 is like 6 because if we draw this out, so first, draw a right triangle, put these links here, okay? Dilated, so the image has the side links now of AB prime, BC prime, CA prime. So instead of giving the links here, that gives you the image links here. What is the scale factor? It's going to be the same thing. So you look here and you say, well, I have my pre-image 13. What do I multiply that by in order to get 26 over 5? Okay, so I think that this is actually easier to do. Let's see what 26 over 5 is. All right, so we have 26 divided by 5, 5.2. Okay, so 5.2. So how did we go from 13 to 5.2? 13 times something gives us 5.2. So I'm going to take the 5.2 and divide it by 13. And let's see what we get. Scale factor 0.4. All right, let's see if this works. I'm going to use CA and CA prime because if 5 times 0.4 is 2, then we know that 2 of the sides have grown in the same way. That means the third side has to have grown the same way. Okay, let's see what we get. Oh, we got 2. Okay. So we have 2. Our scale factor, let's see if we got 13, and we times it again by that 0.5. Actually, let's do the middle one. Sorry. Let's do BC. 12 times 0.4, which was our scale factor. And we get 30. Uh-oh. Wait, what happened here? I think I missed this a bit. All right, 5.2. All right, divided by the 13. 0.4. Okay, so if I multiply this by 12, 4.8, good, okay. And you guys are like, what is he doing? 4.8. It's going to be the same process as up here. Basically, you're just saying, okay, here's my pre-image, 13. What do I multiply? So 13 times x. What do I multiply? 13 times x to get our image, 26 over 5, which again, 26 over 5, whoops. 26 over 5 is the 5.2. So what do I multiply 13 to get to 5.2? We multiply by 0.4. So think of it. 13 times what gives you 5.4, 5.2? 13x is equal to 5.2. We divide by 13. That's to get what x is. 0.4. Now that's a scale factor. It is a reduction because look, it's getting smaller. We can see it's getting smaller by this side alone, okay? So it's a reduction. It is a reduction with a scale factor of 0.4, and it is a dilation because all the sides did change in the same way. All right, I think that's it. So we are going to go ahead and stop this. All right, thanks.